All right, let's talk about how to name binary molecular compounds. Binary molecular compounds contain only two elements. It's usually two nonmetals or a nonmetal and a metalloid. It can't include any metals whatsoever. A good indication you've got an ionic compound is you see a metal, or sometimes you see more than one or even more than two nonmetals. If you see more than two, that's not going to be binary molecular because binary means two. Usually the more metallic elements written first. Exceptions include ammonia and halogens with oxygen. Usually then the other is written first, but they'll be given to you in the proper order for this one. Greek prefixes indicate the number of atoms. The first element is named, and then the second one gets an IDE ending. Mono generally does not precede the first element. If there's an O or an A at the end of the prefix, we usually drop it before oxide. For example, carbon monoxide. I dropped the mono that would be appropriate for the carbon, and I dropped the O for the mono in front of oxide. Instead of being monoxide, it's monoxide. These are the Greek prefixes. Mono is 1, di is 2, tri is 3, tetra is 4, penta is 5, hexa is 6, hepta is 7, octa is 8, nona is 9, and deca is 10. So now we will practice some binary molecular compounds, go name to formula, or we will go formula to name. All right, let's look at these binary molecular compounds. Nitrogen trifluoride. Remember, we omit the mono from the first element, so that means there's one nitrogen. Trifluoride, that means there's going to be 3 fluorine atoms. I don't use charge. I just use the prefixes to determine how many of each thing. So in some ways, these are the easiest ones to do. Dichlorine monoxide, so 2 chlorine, Cl2. Monoxide, just one oxygen, Cl2O. N2O4, that means 2 nitrogens is dinitrogen. And 4 oxygen. So we're going to write the tetra, but we're going to leave the A out. So tetroxide, omitting the A in the tetra. P4S10, so that's tetra phosphorus. Then 10 sulfur, so deca sulfide. And that would be the answer. There are some binary compounds of hydrogen that end up being a special case. By convention, we generally omit the prefixes, even if they would be appropriate. Compounds are generally gases, but if you dissolve them in water, they tend to form an acid. For example, HCl in the gas phase is hydrogen chloride, but HCl aqueous means dissolved in water, forms hydrochloric acid. Usually people don't keep hydrogen chloride gas around, so if you see HCl with no context, you're probably talking about hydrochloric acid. So then we're going to name a couple of these hydrogen-containing ones, or we'll give the formulas in the example. Okay, let's look at these binary acid gases. Hydrogen cyanide, so it's just going to be HCN. This gas is really poisonous. It's a gas phase element, and that's really what they call death chamber gas. It's toxic on inhalation. Hydrogen bromide, be HBr, but in the gas phase, not aqueous, it's hydrogen bromide and not hydrobromic acid. H2S will just be hydrogen sulfide. This particular gas stinks to high heaven, and so you'll know it when you got it. It smells like rotten eggs. HF would be hydrogen fluoride. That would be your answer.